Okay, welcome everyone. Thanks for joining us today. We appreciate you guys being here. We've got HARC weatherization, climate proofing, Texas homes, HVAC, energy codes, and resilience best practices. So we'll go through some of this stuff real quick. If you were familiar with or if you've been on the last webinar that we had, some of this will be kind of repetitive, but some of it's pretty new, dealing with resiliency and climate proofing. So those that don't know who SPEAR is and what we do, SPEAR stands for South Central Partnership for Energy Efficiency as a Resource. And of course, what we do is do training, webinars, in-person field training, as well as IECC test prep as well. We are member-based. We do cover Texas and Oklahoma. There are other RIOs throughout the country that covers a majority of the United States. There are some states that do not participate with the RIOs, but the majority of them do cover a lot of states and help out with code and weatherization. Benefits for home weatherization. Some of this is just self-explanatory. It's basically our biggest goal that we're trying to do is reduce the energy bills. So we're also trying to increase comfort as well, because if the homeowner is not comfortable, they will change the thermostat. If they change thermostats, it increases the energy of the building on the consuming side of from the building. And then, of course, enhanced indoor air quality. That's becoming even more of a concern these days. As the tighter the home gets, the more contamination can build in the home. So we're looking for an enhanced indoor air quality. Plus, there's a lot more things that are out in the world that we worry about getting into the home. So that's why we have that indoor air quality being part of what we look at. Reduced environmental impact. That's just the off gassing or gassing of the appliances. If you can reduce the usage of that, especially with the gas furnace, you can reduce its output of greenhouse gases. And then, of course, the increased home's value. If you have a way to show that your utility bills have dropped because you've had weatherization done, you can actually put those. A lot of realtors are now asking for 12 months bills. And if you can show a substantial savings because it's been weatherized, sometimes that's a big checkbox for the homeowner that's looking to potentially buy your house, is to say it has been weatherized, it's lower energy consumption, therefore it's more comfortable. And that leads into also longer lifespans of the HVAC system. It's been addressed and tuned up. So it's advantageous for homeowners to look at that, to say that's something that they're going to actually start looking for, is those kind of things. And it can reduce noise pollution, also decrease the chance of condensation and mold. Well, you're controlling humidity from outside, but you have now humidity that can build up inside. You just got to know what's happening with that and how to potentially mitigate that. Enhanced durability and reduced maintenance on the equipment as well and the home itself. And then, of course, energy independence. The more you can reduce energy consumption, the more likely, if they decide to do a solar program, that they're now energy independent and they don't have to rely on the grid itself for getting consuming energy. That's a longer story about how that works in blackouts. But why climate proof matters. And so Texas homes still face today rising temperatures, severe storms, and we still have energy grid stress. And so we're still working on the infrastructure. There's bills that are being passed to fund the infrastructure improvements, but we still have a grid that is vulnerable to having stress on that. So homes built to older standards and or have not been weatherized are more vulnerable to the health and safety risks. And then modern codes offer proven strategies for protecting families and properties. So they use historical data and having pipes freeze, and that's why pipes have to be done differently with the codes and how they have to be insulated differently. And there's a lot of things that modern codes have now addressed how we didn't think about it in the past. So climate proof using updated energy codes. Some of this is just, again, part of what we do and what we look at for building durability is improved thermal envelope. You guys, if you're in the weatherization crews and you're here online, thanks for being here. But you're looking to do improvement of the thermal envelope or the air barrier and combining those two. So lowering the air infiltration of the building, as well as improving the thermal envelope with increasing insulation in attics and knee walls, anything that you can access in the home to get more. Basically, we're looking to hold down heat transfer into the building by slowing down that transfer through the insulation. Enhance the HVAC efficiency, so you're tightening ducts, you're sealing up leaky ducts. You're kind of sometimes looking at heat exchangers, making sure they're not cracked and making sure those things are running at tip-top shape and that they don't need to have any additional service. Of course, there is now mandatory mechanical ventilation. The tighter the home gets, and that's why it's in the code, is now that we have tighter homes, we need to exhaust or dilute contamination inside the home. And so when we do that, it lessens the impact of people having respiratory issues or feeling a little under the weather due to a buildup of parts per million inside the house. And then, of course, increased resilience to the grid string. We've talked about that one. Durability against moisture and mold. We talked a little bit about that. The more you air seal the home, the more the potential of a condensation or dew point inside the home can move. And then solar and EV readiness. We talked about that a minute ago. Energy independence. So if they add solar, their light bill and power bill is reduced significantly, but the best thing that you can do is weatherize a home, lower its energy consumption first, and then not have to buy so many panels to have it energy independence. And then lower utility bills for the homeowner. That's our ultimate goal, and is the comfort and health and safety of the occupant. And then, of course, wildfire and storm resiliency options. I used to think the wildfires really didn't pertain to Texas, but we had that in the panhandle of Texas. It is a big problem. And of course, if the home is leaky and has a lot of infiltration, those winds moving that smoke through there is actually just permeating into the building and making a health and safety concern. And then, of course, Winter Storm Uri. If you're in Texas and you're familiar with what happened, most of us probably are. This is just kind of a highlight of what happened. Now that it's several years old, we've got basically 246 confirmed storm-related deaths across 77 counties. Victims basically range from infants to 102 years old. A lot of those happened because people could not stay in these buildings. They had to get evacuated. And if emergency services could not get to them and they tried to shelter in place and it became unlivable conditions, then some of them passed away due to that unlivable condition. And of course, independent estimates, some of them are actually analyzing this and saying it's actually much higher than that. BuzzFeed News basically investigated and estimated it was like 426 to 978 deaths. The best estimates around 702 fatalities. So it's a lot worse than we think just by looking at the highlight reels of just the big topics. And then power outages and water outages, we had all that in Texas. Most of the power outages, it affected 400 or 4.5 million homes and businesses, and a lot of them extended beyond several days in a row. It wasn't just 8 hours here and then the power was back on. It was for several days. That made it a health and safety concern, that made it to where they could not shelter in place and they had to be evacuated. And if you were here in Texas during that time, the roads were pretty much impassable. There were down power lines, there were down trees. It just made it harder for a lot of people. So in that death toll was probably some first responders that were trying to do their best to get to people and they just didn't make it. And then water disruptions. So nearly half of Texas residents, about 14.5 million, experienced water service disruptions due to frozen pipes. And of course, most of the damage that is occurring is because once the pipe thaws, now you've got damaged homes and you've got ceilings falling in and people cannot stay there as well because it becomes a health and safety issue again. But we still have other Texas weather extremes. So low records, we've now recorded -2 in Dallas-Fort Worth. We've actually had up to 6.4 inches of snow happening in Austin. So it is, as we see here, since the 40s and in 72 years. So a lot of this is happening recent. So that February 16th was of the same time of Winter Storm Uri. So it is having extremes, and people need to be able to shelter in place longer. And of course, if you look at what happened, why it happened, really what was the cause of failure, it's still just a grid vulnerability. So basically, the electric ERCOT, the Reliability Council of Texas, reported that basically the power grid was basically a 4-minute 37 seconds away from a complete collapse. And so if that did happen, there would be a completely different outcome and a different story to what actually happened. So cause of failure, basically they put it to winterizing a natural gas infrastructure. But a lot of those had to be turned on. They were backups. They had to be switched on because of electric resistance heaters. that caused a lot of increase of energy consumption in places that don't normally have to run heaters, like San Antonio, south of San Antonio, close to the border. People were turning on their heaters that don't normally do that, and it was a really big spike of energy, and the grid just could not handle it. And of course, winterizing is the first line of defense. So we're looking to reduce the heat loss, and that's keeping it out and or keeping it in. So when power failures happen, basically you're trying to trap the air inside the building. That's why we do air sealing. And so if you're a rater on here and you do blower door testing, we're looking at ACH, air changes per hour. How often will that air turn over in an hour, estimated by blower door testing? So you start plugging those holes, and then you start adding insulation. If you've got insulation with holes, once air moves through insulation, it reduces its R value drastically. So that's why, even though you properly insulate it, if you don't air seal around it and trap the air inside the insulation, it's almost as if it's not there. And then, of course, fewer frozen pipes, keeping outside air leaking in or the heat from leaking out, and it keeps the pipes more keep them from freezing. So my house was built in '94. There's copper pipes in the exterior walls. So if I don't have the house that's being conditioned and heated, and I've got a lot of air infiltration through the wall, those pipes are subject to freezing really easy. And of course, then the damage is going to happen, catastrophic damage from water once it thaws out. And of course, an improved indoor safety as well, so homes stay warmer longer. It reduced the desperate measures between trying to get out of there. But also when homes are leaky like that and it becomes a health and safety issue, people pull in. We've seen outdoor grills being put inside the home. We've seen gas-fired generators being put inside the home. They're not meant to be running inside of a home. What they do is consume the oxygen in the room that people are breathing, and then it spits out carbon dioxide. But once it takes that carbon dioxide and tries to burn it through again because it can't get oxygen, now it's producing carbon monoxide. And then that's when it becomes a major health concern. So we don't want to have that happen, but that was happening during Winter Storm Uri. And that's probably what a lot of those tragic deaths were, is from those kind of things happening. And then energy codes building, they're basically resiliencies into every house. So we have stricter insulation requirements now in the codes. We have air leakage standards. So we're doing blower door testing. We're verifying. Those that are on the weatherization, you're familiar with the test in, the test out. You guys don't technically have to meet the code level standard, but you're showing a pattern of improvement. You're showing that you can lessen it by X a number of CFM, which is equivalent to X number ACH. And that's how you guys do your work, and to make sure that at the end you test out and it actually meets what you were looking to hit. And that's also due to duct sealing. You're tightening the holes in the ducts. In Texas, we still put a lot of duct work in the attic. So if you're running a blower door and maybe a duct's disconnected or has been ripped apart, that adds to the blower door. So sealing up ducts, making sure they're connected correctly, if they're outside of the envelope, and then that helps lower that ACH in the blower door test. Better windows, if you've got cracked windows, missing panes, if you're replacing some of those, then basically you're looking to hit newer code standards for U factor and SHGC have been improved to keep either heat in or heat out of the building, depending on what part of the climate you actually live in the United States. We're worried about keeping cool air in and keeping heat out. Other windows up north are just the opposite. And then, of course, mechanical ventilation standards. We're looking for what we always call fresh air. So it's critical during shelter-in-place emergencies. If future buildings, basically right now mechanical ventilations are kind of elementary. They work on a timer or some kind of program that's set. They don't have a sensor that says, oh, I have a lot of parts per million contamination, I need fresh air. It's just going to run at a certain time every hour. But I can see in the future we have sensors placed everywhere. And if for some reason someone's decided to pull in a generator and now CO2 is being emitted inside the home, or CO is being emitted inside the home, it's going to kick on that mechanical ventilation and start exchanging the air to the outside. Unfortunately, if it's -2 outside, you really don't want to do that. So basically, we're just looking to try to make sure the standards are met and that air does and can make it inside the building in case there is an issue with contamination. And then climate resilience starts at the home. So weatherizing, being code compliant. Again, if you're doing weatherization, you're not really looking to meet a new code standard. You're looking to meet what your software is telling you that you need to do. And that's air sealing of the house and better insulation and tightening up the ducts and testing the ACH and testing duct testing and making sure you're getting it to where you need to do. And actually, you're looking to air seal the home by caulking windows and doors, any openings that you can find in the envelope itself. So weatherized, code compliant homes are not just energy efficient; they're also crisis ready. We like to call them crisis ready. So temperature extremes, extreme weather events, we can actually be crisis ready and be able to shelter in place longer. Tighter building envelope offers the entire community's peak demand. So basically, it's if everyone has a tighter home, if everyone had a tighter home, then it will consume less energy as a whole, so that specific sections of the grid will not be stressed out. And resilient homes save lives by keeping people warmer longer or keep them cooler longer, especially in Texas during the hot summer heat. It reduces the financial fallout of disasters like frozen pipes, water leaks, and total home loss. And then, of course, investing in energy efficiency is an investment in emergency preparedness. It's basically a proactive resiliency, not just a reactive rebuild when something gets damaged. So that's kind of what we like to say happens with that. So first and foremost, when you're going to weatherizing, some of this stuff may be elementary to you guys, but those that don't fully follow weatherization might be new to you. But we just both first thing we do out of the gate is assess the house. We walk around the home, we look at things, we find out is there gas appliances or is this house all electric, because that will determine your next step. If it is a gas appliance, now you're looking at, is it in the home's envelope? If it's in the attic, no big deal. If it's in a closet in the hallway or the front foyer or it's in the kitchen, that now brings up another level of challenges that you now need to make sure, if I air seal this house and tighten this home, is that going to affect the gas appliances and it breathing air for combustion? 9 times out of 10, it probably will. So what you want to do is now exclude that gas appliance from the home. If it's going to be replaced, maybe you can relocate it. If you can't relocate it, you build a room around it and you isolate it. Bare minimum, you're giving it its air it needs instead of using and consuming the air inside the house. Count all exhaust fans, including bath and kitchen exhaust and utilities. You'll have to do a worst case depressurization. So you're going to need to know where all these are so you can turn them all on when you're actually performing the test per the standards. And then you enter the attic, assess what type of attic insulation's there. Could be potentially an issue. Vermiculite is one of those back in the 90s and before and prior to that. It could contain asbestos, and if it does, you kind of really don't want to run a blower door test and depressurize the home if you've got that in the attic. So basically you're just assessing the home and saying, what do I need to be concerned with? Making note of that so you can address that as you go through your steps. So the next thing you're going to do is basically you're identifying the thermal envelope alignment. So where does it start? Where does it stop? Where is the air leakage that I need to look for? Where's the insulation that I'm looking for? If I've got knee walls on the attic, am I looking at insulation? If I see the backside of insulation, it really needs to be encapsulated with OSB or T-ply or something that's going to encase that into an air sealed box. And you're trying to cover up all the insulation, not the attic floor, but anything that's vertical. And you're looking for scuttle holes. You're looking for, is it connected to the garage? If there's a floor over the garage, is there some connections to that you might need to seal off? And then you're looking for open chases. I know this is probably something you guys see a lot in older homes, but flue pipes, water pipes, gas lines, water heater flues, fireplace flues, all of these that are shooting up through into the attic. A lot of times they used to just they don't want flammable material touching some of these things, so they just make a big hole around it. Well, that in our world is air movement through and in and out of the building, and is cause for concern when you're trying to seal off the home to meet an air changes per hour. So that's a misalignment of the envelope. This is basically what we would call an extension of the attic. If I can step through that and fall to the first floor, that's an extension of the attic, and all of this needs to be addressed. Either sealing it off around the level you're looking at in this picture, or sealing it off all the way down that chase, all the way to the lower floor. This can be any kind of piping or electrical or anything that's through that. So they must be sealed at the attic level instead of trying to let this chase go all the way through, because all of the walls surrounding this chase are affected by air and for infiltration of heat through the building. So then also insulate on the top if you can do that, but keeping proper distance from fireplace, water heater, and stove flue pipes. That's the best way to make sure that you're not putting someone in a safety issue. This is a gentleman that's just blocking and sealing around the fireplace. Big chases around brick fireplaces. It was predominantly done in the older homes. But this guy is sealing it up. If you see where he's at, he's using poly seal to seal the holes. He's cut what looks like radiant barrier decking and or foam to plug the big holes. He's used fire caulk around all of the studs that are meeting that, all the ceiling joists that are meeting that. Any place that he can that's going to be in contact with something that could be hot, but it's still allowing for flexibility when something moves as far as brick and wood, expanding and contracting at different levels. So that's a good way to seal that up. Rule of thumb I always told my guys when I train them is look for dirty insulation. If you've got yellow, if you've got white, if you've got pink, you can find these areas. This isn't just dirt settling on specific areas and not touching the rest. This is a filter has air moving through it. That's why it's collected the dirt, is because that's where the air is moving in and out of. Most likely it's moving back into the home. It's filtering through the fiberglass. This is evident that there is air leakage happening behind it. So having to remove this and sealing that. And also, same thing, if you find spider webs only are made where in areas of air movement. They're trapping things that are moving through air currents. So if you start seeing a lot of spider webs, 9 times out of 10, that means that there is going to be an air leakage somewhere, and they've built it within the airstream of that hole. So always looking for those telltale signs to be able to get that sealed up. This is on the internet. Probably you've seen this 100 times. But basically, it's just a cheat sheet to look at it and go, what are my common area attic leaks that I'm looking at? Basically, it's around piping, HVAC boots, can lights, bath fans, flue pipes. Anything that's connected to the ceiling is going to be a potential air leak. So pulling down the grill around the bath fan and looking at its housing, even if you caulk around that metal box, that box itself has holes all in it from the manufacturer. A lot of times taking plastic tape and sealing that will help lower that air infiltration through those bath fans. Then, of course, air sealing in the attic. I know you guys don't always have the benefit of removing insulation and air sealing. This is a picture of a house that did. They removed the attic insulation. They were able to see every single hole in the envelope. I don't know what all those little dots are, assuming that it's some kind of roof cover on the interior side. They had to drill holes through the sheetrock, but all those need to be sealed. Electrical boxes, around plumbing, if you can. If it's not a fire hazard, you can use the orange foam that's here has a fire retardant in it, so you can put it around flue pipes. However, you have to look at manufacturer's instructions to see if you can. Around dryer vent pipes, any penetrations through the top. You guys probably have some of these things in your trucks. This is a field-made box around a can light. The older can lights had vents in it to keep the light from overheating. There's also safety switches that if it does overheat, it will pop the light off until it cools down. It will kick back on. But the box that are here, basically you're just creating a box around it to air seal around this can light, and then you're allowing it to have insulation on it. New code now requires it's called ICAT, I-C-A-T, so it's insulation contact airtight cans, which means none of this has to be addressed. If there are ICAT labeled, that means you can throw insulation on top of it, and they are air sealed to a certain standard, so you don't necessarily have to be concerned with this. They still have to be sealed to the sheetrock, and if they're not, and you pull the bezel down and it's not sealed to the sheetrock, that does need to be sealed. There's other ways to do that. There's little dome cardboard or styrofoam pieces that you can just dome around it and then polyfoam it. That's another solution there, but putting insulation against older cans is not advisable. There are cones like this that can be popped up inside the can. If you cannot access it from the attic, you can pop these up. There's a gasket at the top, there's a gasket at the bottom, and once you've popped those in, you've basically air sealed the can. The hesitation for this is you cannot really put back an incandescent bulb. So if the homeowner has an incandescent bulb and you put these cones in there, it's best and advised to go back with CFL or LEDs at the best, because if you don't, it's going to overheat and it's going to start shutting off that can light. Or these domes they're made out of metal, but they could heat potentially and then shut off the switch that's inside the can. So it's a great retrofit option, but just know that you got to replace the bulb itself too. Insulation, we talked about it a second ago, but always has to be six-sided encapsulated if you can access it. Top, bottom, side, front, back, that's six sides. Air moving through insulation lowers its effective R value, greatly diminishes the R value. So you should not walk up into an attic and see the back of insulation. Older homes, my house built in 94 looks just like this. I've yet to seal the back of them, but it looks just like this. They're not hanging down. This is not my house, but it looks just like this. We have 2x6 framing. I've got R19 that's facing me. I should not see that insulation. I really need to get in there and air seal it, but I have not done that. But new homes, it all has to be blocked from all sides. You cannot leave insulation exposed to an attic. And of course, this is kind of just a diagram that's online that I picked up that's basically air sealing knee walls. This one is it's got a lot of other moving parts. This is a second floor over another first floor conditioned area. So you have part of an attic that has ceiling insulation, and then you've got a vertical pony wall, attic wall that also has vertical cavity insulation for the wall. But if you look in the lower right-hand corner, you also see blocks that are blocking off the subfloor from air moving into the subfloor. There are gaps between 2x4, 2x8 OSB boards, so air will move through the floor. So you have to seal it at its extreme and create a band joist around the base of that second floor room, kind of like this. You're basically blocking this off. You're building a band joist that should have been there when the house was built. This was probably not code required because the house was so old or older. They don't have to have it sealed off, so you could basically move air or push through or crawl through the subfloor of that room, and you don't need to have that. So all of those have to get blocked, and then insulation will be put back right against it. So blocking off subfloor openings. We showed earlier where all the insulation was removed. Here, instead of removing the insulation, they just take a broom and they just kind of sweep away, and you find the exposed top plates. You guys are probably familiar with doing this. You poly seal all the gaps, all the seams between the wall, the top plate, top board, and the sheetrock gaps, and you make sure those are sealed. But you're also looking for wire holes, electrical boxes, can lights, HVAC boot. I'm sure when you assess the house, you're making note of the number of can lights that you need to access to get them air sealed and how you need to do that. And then also looking around kitchen vent pipes, making sure those are sealed properly, and just getting all that sealed up. And the bath fan housings, you can seal them from the attic side as well. Or if you can't access it because it's in a cathedral or vault, then you're sealing it from the indoors. And then attic insulation, right now the 2018 levels that I believe the weatherization is still following is climate zones 3 is 38 and climate zones 4 is 49. And so just depending on how you guys, this is just code. I say it's code. It's not necessarily what you have to do in your program. You're going to base that on what you're putting into the software and how you're going to improve the house and show an energy savings. But baffles, if you don't have baffles installed, it's an older home and you've got soffit vents with vents and there's no baffles at those vents, it's advised if you can reach it without too much disruption to the attic insulation is putting baffles in to keep air from washing through that insulation in the attic, because if you do, you lower its R value. It can also blow off the top plate, now leaving the top plates exposed, and they should extend beyond the height of the blown insulation. And then, of course, insulation should extend all the way to the outside of the edge, so you should not have or should not be able to see an exposed top plate. Insulation should cover that. And then what's new in the code, and I think you guys have this in your requirements as well, is you're going to start doing insulation damming. This is showing OSB board or basically it's plywood. Most people aren't going to use that because that's too expensive. You're going to use something else. But it needs to be a permanent means. It can't really just be cardboard or things like that. It needs to be permanent. So you can use netting. You can use T-ply if it's framed correctly. If it's not, the T-ply will fall over time. You could use OSB. You could use styrofoam board. But basically what you're looking to do is have a full height of insulation all the way to the outside of the top plates. That's separating ceiling height changes. That's separating conditioned from unconditioned attics or over an unconditioned floor like a garage compared to over a conditioned floor like a kitchen area. you're going to put that block up. But if you have a ceiling height change, you're doing the same thing. You're keeping that insulation to its extreme level all the way to the outer edge. Anything less than that is less R value in the ceiling. And then, of course, scuttle holes, getting those insulated and weather stripped, that's also a code requirement, as well as I believe it's also your requirement for your weatherization. And then some of the stuff we'll go through right now, and I apologize for going quick. There is a lot of slides, but there's a lot of information to cover with this. But HVAC code basics, and basically its best practices, is you're trying to get resiliency in the home. You're trying to air seal the HVAC stuff. You're looking at sealing up the duct boots, seal and prevent for energy loss during, when they're trying to cool and heat the house, they're losing air to the attic. You don't want that to happen, so you're sealing it. But also what's coming in the code and what's in the code for new homes and what's coming to the code for existing homes is proper sizing, making sure the house has the correctly sized equipment in it. It may be functioning properly now because of the air leakage, but once you tighten all that up, it could be oversized and it causes another issue. Proper airflow through that and reducing heat buildup inside the building and pressure differentials. Also, you're controlling dehumidification and mold growth inside the house potential. So some of the highlights here in the 18 and the 21, you've got like R8 ductwork that's happening. Your program may allow you to do R6 or you're doing R8 all the way up to the 21. It used to be, depending on where you're located, the ducts are located, depends on what kind of R value. Now in the 21 and beyond, it doesn't matter where the ducts are located. If it's 3 inches or bigger, it has to be an R8. If it's 3 inches or less, it can be an R6. It's not reliant on where the location is. And then, of course, air sealing the ducts, the air handlers, the filter boxes, the plenums, joints and seams must comply with the IMC or the IRC. Basically, you're just looking to seal up everything you can get a hold of, making sure that whatever's being sealed is 181A UL type of system. Even if it's a flex tape, it needs to be 181B, and 181A is for metal. Then you're going to, of course, you're sealing all the connections, the flanges, the collars. You may have to pull the insulation back at the plenum and be able to seal the collars. And if you have any kind of metal duct that's there, you're basically crimping the joints and making sure they overlap and making sure that the screws are still there and they haven't popped out, and then you're sealing all that as well. Duct testing, and there's a pressure difference that you're using is 25 pascals. If you do that on a daily basis, you're used to that. It's just a pressure differential from what's in the duct to what's outside the duct, and you're trying to equate that to a CFM. We're still looking at 4 CFM per 100 square feet of conditioned space. So if the house is, 1,000 square feet, you're looking for 40, and that's kind of the rule of thumb. So code still requires that to be 4 CFM. I know in your programs you're going to do the best that you can and try to get to that 4. Sometimes that's kind of impossible if you have ducts that are inaccessible, that you cannot reach some certain ducts. There may be some leakage going on in there. And of course, in code, you cannot use building framing cavities. They cannot be used as ducts or plenums. I know my house built in the 90s had low wall returns. That's still sometimes used in today's construction, but it's not code allowed. So if you find that in older homes, I know it's too costly to raise the returns up on the ceiling, but trying to seal around any openings that you can really not get down into the chase itself. That's going to be a sign of leakage that you can't really fix. And then, of course, piping insulation or around anything that has fluid that's greater than 105 or less than 55. That also does include the condensate line coming out of HVAC units. It's best to at least insulate that for the first 10 feet to keep condensation from happening. So if you tighten up the ducts, you make sure the airflow is proper, and the air cooling of the ducts is getting lower because you've lessen the leakage inside of that. Now you have colder air, and it could possibly condensate on that drain. So making sure that's sealed, that's part of code. And protecting the pipe, this is basically dealing with the line set that's outside. There is now code requirement that says any insulation that is exposed to weather needs to be protected from damage, including sun, moisture, equipment maintenance, and wind. So Armaflex is one of the brands that are out there, but that has to be done. It can't degrade over time with solar radiation. And then, of course, mechanical ventilation must follow the mechanical code of M1505. There are some things in the energy code. The majority of it just points back to the mechanical code. But the outdoor air intakes and exhaust shall have automatic gravity-fed dampers. automatic or gravity fed dampers that close when it's not operating. If you have an exhaust, you can put a gravity damper. If you have an intake, you can't put a gravity damper. It must be an electronic damper that's now connected to the system. And equipment sizing, I won't spend too much time on that, but doing manual J, manual S, I don't know that that's a weatherization thing, but it is in new construction. It is coming to the existing buildings. When someone changes a system out, it has to be sized properly. So I won't spend too much time on that, but it's called the manual J and S. J tells me how much heat is coming in and out of the building in BTUs. S tells me that my equipment can now match the BTUs that's coming in and out of the building. I have a question here. It says, would you use a copper line set cover to protect the system and copper line? Yeah, that's exactly what I was talking about, Guadalupe. It's just you're looking for protecting the copper lines. So it could be plastic, it could be a PVC, it could be the Armaflex is more of a foam, but it has a harder outer casing that keeps it from deteriorating. So yes, you need to make sure that that's properly protected from all those things that we listed. Manual D is kind of really not in the energy code right now, but it is coming. I believe it's going to be, I think it's in the 24. You now have manual D, which is duct design. It won't be what you guys are looking at, but looking at the house itself and kind of drawing a mental picture of where are ducts connected, how are they splitting off when you're looking at sizing, and maybe there is a room that is not comfortable enough. The homeowner tells you this room is always hot, and now you're looking at it and realizing that the way that they've split that thing off, no wonder there's not any air, is because the majority of it's going to the rooms before it gets to the last room in the house. And so looking and making sure that the ducts and the duct design can at least meet that and meet CFM to reduce BTUs and heat in those rooms is always a good way of looking at it. And of course, duct installation practices. This is one thing that if you're not installing ducts, but you're looking at the ducts, make sure that it's, and you'll see it in a minute, it's the 3 S's, straight, smooth, and sealed. So basically it says, it came off ACA, so it's install flex ducts as straight as possible, fully stretched out without unnecessary sags, crimping, or bends. Energy Star points that out a lot, but it's also in code because code says you must follow the manufacturer's instructions of installation. So not having bends that are greater than 45 degrees. The rigid connectors that are joining the two pieces are actually sealed. And then, of course, you minimize the static pressure and maximize airflow if it's done properly. This is just one that we saw out in the field. It's the inner lining is missing, and somebody just strapped the outer mylar lining. That it can be big problems inside the ductwork. But having excessive loops, this is the 4 S's, smooth, sealed, straight, separated. In Texas, in the humid side of Texas, if ducts are laying over the top of each other and in contact with each other, there is a much higher potential of ducts sweating. And if they start sweating, then it's raining the ductwork, water on top of the insulation, and eventually it's going to make its way into the sheetrock and show staining inside the house. So keeping ducts to those 4 S's is its best practices when you're installing ductwork. This is kind of not really used in today. They use other means like metal Ys. But these things, when you find in existing homes, are notoriously bad for leaking. The tape will pop, so you've got to go back and try to seal all those things up. This is where a lot of condensation will happen as well, and it can build up potential health hazards, safety concerns inside of that. But metal Ys, having those done correctly, if you're going to replace any of those transition boxes and you use a metal Y, use one that's not going to add to the restriction level. And you're basically, it's a smoother transition from one to the other. No cuts and stabs. We still see this even on some homes today. It's out in the rural area. It's not a lot of enforcement. We're looking at it, but instead of having a metal Y in the truck, they either didn't have it or someone didn't supply it with them, and they just kind of cut the outside duct and just cram the other duct into it and then try to seal it up as best as possible. That's not going to happen. If I was standing at this house and you could push in the middle where all the mastic is, if you could push that and it collapses easily, then there's no structure in there to keep that from being a problem. That really needs to be taken apart and a metal transition to be actually installed. So not having these things that way. So if you're looking at existing homes and you see that, that's an area that you can immediately start fixing that problem. Not much you can do about this, but in new homes, it's best to follow the allowances for clearances on supply and returns. You should not have any ducts at the end of a plenum that's within 18 inches. You reduce the impact of high static pressure points. You build the plenum big enough to where it can handle that amount of airflow. It also ensures and balances air pressure. Air is not smart. It can't just make hard 90 turns. It runs into something and then it bounces off and causes static pressure. That's how air goes down ductwork. If they're not installed properly on the plenum, it's going to cause more of a higher static pressure and cause a restriction of airflow in the ducts. This comes straight out of an ACA manual, just talks about better supports of the duct system. So if you've got a duct coming off of a plenum or a trunk line, you need to support it. The rule of thumb here is basically whatever the duct size is, the first strap needs to be within that same distance. So if it's an 8-inch duct, you need to have the first strap at least 8 inches away from the connector, and then you can move on from there with the duct system. There's a lot wrong with this picture, but you've got a lot of ducts that, some of them are laying on the floor. A lot of them in the very back have sags. There's sharp bends. There's kinks. There's ductwork at the end of the plenum, not allowing for the 18 inches at the end. There's just a lot wrong with this one. So again, if you're not replacing the plenum and you can't relocate ductwork, there's not much you can do about it. But just know if you go back with like for like, you may still have an airflow issue. So addressing that could be what you need to do. We just saw one in real life that looks like this as well, but just having a sharp bend like that causes friction loss of airflow. Even though someone thinks a ductwork can handle 200 CFM, if you bend it over at a 90, you're not getting that 200 CFM out the other end. You're going to get reduced because of friction loss. This is a good example of that, is having something that looks like this. Doesn't mean that just because that's pushing 1200 CFM that 1200 CFM is actually happening. It's not. It's going to cause a lot of friction. It's going to cause a lot of back pressure into the system. It's going to be a premature failure of the system just due to this pressure it's trying to overcome. So best practices is not to do it, especially like this. Same thing here. Coming right off of a plenum and then basically just bending over. I understand sometimes it's hard for them to install the duct when there's only 2 people, but if you see something like this, this should be called out. It should be fixed and mitigate the bend in the ducts, and that will increase the airflow on the other end. We just talked about that, but rule of thumb is the inner duct diameter determines how much you can bend the duct. So if it's 10 inches, it's a 10-inch radius. If it's an 8-inch, it's an 8-inch radius. Anything beyond that causes much, much higher friction loss. Same thing with bends that are in the attic as you're hanging them through there. You should support them on both sides, not just one support in the middle. One support in the middle causes it to have friction loss. Doing at least one diameter of ducts on either side lets it be at least a gradual turn and allows for better airflow. Sagging, we saw what that picture looked like a second ago, but having sagging ductwork also increases friction loss. Basically, the recommended is no more than ½ an inch per foot. If this is a 4-foot span, you can't have more than 2-inch sag in that middle. If you do, it's increasing friction loss. It's lowering CFM to get to where it's actually supposed to go. And then you don't see this a lot because it's not accessible for existing homes, is having vertical chases. You got to make sure that those are also strapped properly to keep it from sagging down on itself as well. Kinks and sharp bends should be avoided at all costs, even laying over framing members. Laying over a framing member can cause it to crush, not to mention we're worried about heat transfer. If that's 160 degrees in that attic, then the roof support that it's leaning against is 160 degrees. And that heat is transferring itself directly into the ductwork. It can increase condensation inside the ducts. So if you're in an existing house and you see a vent and it has rust on it, that means something's being condensated either at the ceiling or it's condensating further down the duct line and it's causing it to blow out of that vent. So just looking at the duct run and see if you can see, is it leaning against the roof? Is it leaning against the framing member? Because if it is, that's probably its point of condensation. And water is making its way to the vent. And then fully extend. We talked about as straight as possible. I know you sometimes can't do it without crushing the ductwork, but straps are placed at the position they're supposed to every 4 feet. And then you're pulling the ductwork to at least, as best you can, the picture at the bottom. Most of the time we see the one in the middle, which that's giving you about a 15% friction loss. So you cannot overcome it 100% with flex ducts. You can with metal, but not with flex, but you do the best that you can to not have compression in the ducts. That gives you a better airflow. And then, of course, looking at mastic and sealing that up, the rule of thumb from ACA is you need to apply 2 inches of mastic on every collar. And from the end 2 inches in, you need to have mastic, and the thickness of that needs to be the thickness of a nickel before you start putting the inner liner on. If you put the inner liner on and you can see brush strokes and you see metal showing, that's not enough mastic. It's got to be enough to actually be the thickness of a nickel before you put the inner liner on, before you strap it down. You need to make sure you have plenty of mastic, and then you can mastic around it afterwards and to cover all that up. But just masticking on the outside but not masticking the collar or the fitting, you're still going to get air leaks. And then if you do anything like this to help better balance pressure and airflow inside of the building, if you're using these dampers, it's best to install it this way, which is horizontal. So when it's opened, it has less friction, or it doesn't decrease or cut into the airflow. If you do it horizontally, if you do it horizontally, that's the way to do it. If you do it vertically, you're now having air slam into the side of that, and it's bouncing back, and it's decreasing the airflow down the ductwork because it's a higher static pressure at that exit point, and it's causing air to go a different direction. So installing those properly per manufacturer's instructions, always best to do. And then, of course, making sure you're using Panduit straps and the tools to do it. You cannot just do it by hand because it's still going to leak. Using the proper tooling to do that. And then, of course, putting the insulation over the top of that. And then mechanical ventilation, there are many, many ways to do this out there. There's the Honeywell Y8150. But the big concern is why do we need to ventilate anyways? If you've gone through training for the weatherization, you've probably already seen this. A lot of people say houses need to breathe. Well, they do, but we're going to control how often and when by using mechanical ventilation. So now that we do that, we have different ways of doing mechanical ventilation. But just to name off a few, houses, are they really contaminated, especially if it's a new house? If it's an old house, of course. If it's a new house, you still have glues and paints that have VOCs. You have insulation off-gassing. You have cleaning products inside the building. You have products that are off-gassing from cooking and fuel-burning appliances inside the building, like a gas stovetop or a gas oven. Then you also have electronics that are producing ozone. That's a parts per million contaminant that most people may not be susceptible to, but they could potentially have a health hazard with that. So you want to exhaust, or you want to supply air to dilute it. So that's kind of what these diagrams have it here, is this is supply only. We're slightly pressurizing the home. It's trying to push air out of the home, but it's slightly pressurizing. This is the best method for humid side of the country. So in Texas and in Austin and in Houston and Dallas and Fort Worth, this is the means that almost everyone follows, because you're not worried about having stuff come to the house and go into the walls. If you use exhaust only, which is what this describes, you're now depressurizing the house. You're pulling unconditioned air and moisture through can lights. You're pulling it through the walls. You're causing kind of a potential hazard for the building, and you're also just reducing the energy. You're increasing energy consumption because now they have to continually recondition the house because you've got all this other air coming in. So it's not good to do that in hot, humid climates. You can use an ERV. This is what's called a balanced mechanical ventilation. You're bringing in as much air as you're taking out. You're leaving the house at a balanced pressure, and you're also tempering the air, and you're cleaning the air through filters before it gets introduced into the home. You can use, as I said earlier, if you're not in a hot and humid climate, you can use bath and kitchen exhaust, but if you do, they must run. And I think you guys already test the bath fans to make sure they're at least, if it's a continuous, it needs to do 20 CFM for bath fans and 50 for kitchen. If it's intermittent, you guys got to make sure that it's 50 for the bath fan and 100 for the kitchen. So you're testing those to make sure that you're meeting those levels of exhausts on those systems itself. But different types, and I'll spin through this really quick because you guys may or may not use any of what I'm going to show you. But this is just a bad picture all the way around. This is a foam encapsulated house, which we should not see a metal flue pipe. If a homeowner has paid for foam to be installed in their attics, this is a health and safety concern with a gas appliance like this that has a metal pipe. But someone decided to add a what they called fresh air mechanical ventilation and just stubbed it into the top of the air handler. Not the right way to do it. It's a flex duct. It's not really insulated. It doesn't have what appears to have an electronic damper in it. It's just the laziest way to do it, and this should not be allowed and is not allowed by code. But you have the Y8150s. You also have the Honeywell version is Y8150. You have the April Air version of that. These are simple setups that can be programmed to square footage and number of bedrooms and see a film, and now you're stating that you've set it up correctly, but if no one tests it to see what's coming in, you don't know if it actually is doing anything other than opening and closing a damper. So by code standards now in the 21 and beyond, a rater now has to test the airflow to make sure it's actually pulling in enough air that's required for the house. Before that, you just had to have this. It just had to function, and if it did function, it met code. Now with testing, and if you guys have to test this in your weatherization program, you're going to actually try to see if you can hit a certain CFM. It's easier said than done, and a lot of HVAC contractors get a little upset about that because they don't fully understand what it's even there for. There's also Q-Fresh, there's Air King systems. These are standalone boxes. They're not super expensive, but they're not cheap. You know, to buy it off shelf is $200 or $300. To install it's another $200 or $300. So you're looking at $400 or $500, $600, $700 for these boxes. The good thing with these is they consume very low energy. They have humidistats and temperature sensors, so they will not run if it's too hot outside. It will not run if it's too cold outside, and it will not run if it's too humid outside. This keeps it from being a problem inside the home. The Honeywell Y8150s that use the air handler, it's not really conditioning unless you're conditioning the house. If the AC's running, you're cooling it down, you're drawing out humidity. But if just the fan is running, you're pulling all that humidity and temperature inside the home. So this is a good way to do it to lower energy consumption to still get mechanical ventilation requirements met. The April Air is kind of similar to that. This is very popular. It's a plug-in model. They basically pipe it directly into the unit itself. You could just push it directly into the home. Consumes very little energy. There's test ports to test static pressure. So it's easy for raters and third parties to test it to make sure it's meeting the CFM requirement. And then regardless of what it's doing, you can adjust the runtime to actually be compliant. So it's an easy setup. Broan also has one too. It does the exact same thing. And then, of course, an ERV, if you've never seen what it looks like on the inside, that's kind of what an ERV looks like. The air streams don't actually mix. They go through a membrane and just a modulator system that actually has a filter on both sides, and it actually just passes through, kind of like a heat exchanger, and you're changing the temperature and you're removing humidity is all it's doing. But those are maintenance hogs. Mechanical ventilation best practices. This is in the IMC, and I believe you guys have standards that you have to follow as well. But looking at if you're adding mechanical ventilation that's not currently there, it's best to make sure that you do not cause more potential hazards by putting an intake that's close to a contamination source. So if you look at the energy code, it points back at the IMC and it says this is how you need to do it. But Energy Star brought this to the forefront for most residential houses. And basically it's just saying you can't be within 10 feet of a known contamination. That's kitchen exhaust, that's bath exhaust, that's dryer exhaust, that's water heater exhaust, that's even the garage. If it's too close to the garage door, you're going to have contamination. Nathan, I see your hands raised on there. If you want, put that in the chat, a question in the chat, and I'll answer that if you don't mind. I appreciate it. Thank you. And then if you put it through the roof, it needs to be on it needs to stand off the roof deck and not be against the shingles because there is off-gassing in that as well. And then, of course, the inlet should have a rodent screen and a 1/2-inch mesh on there as well. So best practices for water heaters. You guys probably know the majority of all of this that we're going to go through, but this is the kind of stuff that, thanks, Nathan. This is the kind of stuff that I went through when I taught weatherization classes. Was you're looking at the vent piping, you're making sure that it does not have potential condensation that's happening. You'll see rust and water and corrosion that's happening. That's a sign of condensation. You'll see cracks, you'll see damages of any kind, you'll see blockages that's in there for some reason. Maybe it's been crushed and no one really saw that it was crushed. And you're looking for the right supports, you're looking for the slope and the degree of the slope, and then you're trying to determine, is it direct vent or is it B vent piping? And that's going to determine how you're going to shield that from combustibles like insulation and wood itself. So this is a sign of that, and you're looking at it from a single wall. You can be within 6 inches of it, and then with a double wall B vent, basically you're looking at 1 inch from combustibles. I may have that backwards. So double wall, you basically have more, you have less clearance for that, and then the single wall, it gets hot even more, so you're going to have more clearances for that. But if it passes through anything that's a combustible, you're going to look at also putting metal shielding on that as well, and then air seal, caulk, a fire-rated poly seal, fire-rated caulking, something that's going to seal that up to keep airflow from moving in and out of the building through something like this, if you can reach it. And then, of course, the proper slope of the flue pipe, you're looking for at least a 1/4 foot going up, always going up, never neutral or negative. You're looking at least a 1/4 per foot going up and out of the building itself. So that's the rule of thumb to look for if this is inside of the conditioned space. And then, of course, the gas vent pipe termination. Basically follow the requirements of that. It's going to determine kind of what's the slope of the roof. You must install the flashing and the termination cap. And of course, it needs to be 1 foot or more off the surface deck. And of course, that's anything flat to 612. Anything beyond 612, you've got a different requirement. And also, rule of thumb when you're up there doing your investigation and looking at and assessing the home is there a flex line for the gas unit? If there is, it really should not enter into the cavity itself inside the air handler cavity or the furnace cavity. It should have hard metal pipe, not flex line running through it. The picture you see on the right is kind of a concern. They did put strapping, copper strapping to keep the vibration down, to keep it from punching a hole. But over time, the vibration will just wear out the jacket, and then you've got a gas leak in the attic. So that never should happen, and that's code requirement. You look on the left, you actually have a drip leg that's now required for gas lines. That used to not be that way. They used to just stub it directly into the furnace. Now there's a gas line to catch debris and moisture condensation that can drip down from that drip leg. And then the location of the kill switch, if you're going to have to add this to the unit itself, should be mounted, this is code language, should be mounted on the side of the furnace or near a wall, a stud, or the attic purling. But it should be within line of sight of the furnace. It should be easily and accessible. If it's behind lock and key, that's not accessible. And if it's on the other side of the attic, it's not visibly accessible. It needs to be, if you're standing there looking at the unit and you're doing work at the unit, we should be able to just turn around, find the switch easily, and switch it off. So seeing that that's there. And then best practices for water heater, if you've got a water heater, especially if it's inside the conditioned space like this one is. This is a gas water heater. It does have a pan in it. They've got a drip leg on the gas piping. It's got the proper blow-off tube that's there, and it's being pushed down into the pan at the bottom. The flue pipe, it looks like it's probably correctly done as far as going up and out. We can't see where it exits the building itself, but it needs to be completely isolated from the conditioned space. What I don't see here is a threshold. I don't see weather stripping on the door. I can't see inside the closet, but it needs to have a high and low pipe for venting. I don't see a low one that usually is inside the wall, or you can see it all the way down to the floor of the closet. Must also have protective shielding on the flue pipe going through the ceiling. I don't see that. We can't see that from here. But the high and low pipe, the threshold, the weather stripping, and completely isolating it from the conditioned space is what's the biggest concern here that needs to happen. And if you're in the weatherization, you do blower door all the time, then you're not going to be unfamiliar with this, but it's depressurization. How and why does depressurization happen in the home? So if you air seal a home that's tighter and the envelope is tighter, Well, now you have anybody that turns a kitchen exhaust on, a bath fan on, a dryer comes on, the fireplace is going with gas logs or wood burning logs. I'm sorry, wood burning fireplaces system because it has not been set up properly or still has leaks. And then you have inside and outside pressure differentials due to air movement from wind outside can depressurize portions of the home or all of the home. So your job is to determine how would that happen, setting up worst case depressurization, kicking on all the kitchen exhaust, all the bath fans, turning on the dryer, simulating the fireplace by running a blower door at 300 CFM. And so now you're at the worst case depressurization. Run the fan on the unit itself, and now you can set up and say, well, I am depressurizing the house and it's not going to pass because I'm depressurizing the home. So you need to mitigate that if you have a gas fired appliance inside the home. Ways to mitigate that, we just talked about it, but fully isolate the closet from the conditioned space. Consider that an extension of the attic. Weather stripping on the doors. Thresholds are installed. High and low vent piping. That's the top 3 and 4 that's there that you got to make sure that you do so you do not have issues. Looking at that, it looks like the flue pipes always go up. The one right in the middle that kind of looks like it bends down is probably just a kind of how the picture looks. Hopefully that stays at a slope going up at least 1/4 of an inch per foot. And of course they're putting 2 together, the big ones first, and then the little one from the water heater goes into that. You guys will do worst case depressurization by kicking those units on and determining if it's going to depressurize. And then hidden costs of ignoring the code. I know you don't have a lot that you can overcome some of this, but short cycling because the system is oversized. It leads to, costly mold and it could lead to remediation of mold because it's short cycling. It's not pulling humidity out. It's just changing temperature. And then of course, medical costs from poor indoor air quality during heat waves, and then property loss from vulnerable structures. That medical cost thing, that's kind of it depends on if you're more of an elderly person, you may not leave the home very often. So if you've got indoor air quality issues, they could think that they always continue to get flus or they get sick. It may not be that. It may be the parts per million that's built up inside the home. And then your role as a building climate proofing of homes is apply best practices, no shortcuts. Use the 2021 and I say 2021 IECC or whatever your program minimum baseline is. Educate the homeowners as best you can on resiliency benefits, why they have mechanical ventilation, why you're checking it with a blower door, why you're duct sealing and tightening up the ducts. Just explain to them in more terms than you even care to think about because you do it every day. It seems elementary to you, but homeowners are not educated really enough to know what this stuff means from a building science standpoint. So getting them to understand what it is you're doing and the potential benefits of having mechanical ventilation. It's not just a way for you to increase costs or add energy consumptions to them. You're looking out for their best interest from a health standard and a safety standard. And also be part of the solution to climate risks. You can explain to them about, the tighter the home is, the more you can shelter in place longer. The tighter the home is, the less likely you're going to have to replace woodwork due to rot or condensation problems inside the wall. There's just a lot of things that you as a weatherization crew, you actually do that you kind of miss the boat in educating homeowners as to why you do what you do and why you're good at what you do is because you understand building science, that it needs to be relayed to the homeowner that's inside the home itself. So apologize again for starting late. This is my contact information. Please feel free to reach out to me anytime you have any questions, thoughts, concerns. Send me pictures if you want. We'll take a look at those pictures. We can talk about it online, on the phone. We can look at it and address the issues that you're looking at. And anything that I can help with, I'd be happy to do so. So thanks again for your time. I really do appreciate it. I will end the recording here.